Okay, so let's continue with our mass to mole second example right here. So we will be using the same balanced chemical equation as in the given above. So you see that this is the process for the first problem here, following the outline that we have in our paper. So the outline will really help us to be accurate in what we do in every step. So let's proceed to problem number 2 in here. So let's read the problem. It says, how many moles of KBrO3 are needed to produce 74.92 grams of KBr? So the question is how many moles KBrO3, and the 74.92 grams of KBr is our given. At the same time, you see a tiny little molar mass value of KBr here, which is 119.00 grams per mole. So this is our molar mass. So please take note of that. That is included in the given. So let's begin by writing our given value, which is 74.92 grams KBr. Okay, and then we multiply that with the molar mass. So where do we get the molar mass again? Molar mass will come from the given. So molar mass is 119.00 grams per mole. And we have to know that for that molar mass, the value of the gram, which is 119.00, should be placed at the bottom. So we have to put that at the bottom, the grams here. And because that is KBr, of course, you have to attach the substance KBr. And the one on top is always 1 mole, and the substance should be the same. It should still be KBr. Now remember, the reason why we need to put the gram below, it's because the gram KBr and the gram KBr in the given has to cancel out. So that's why we place the molar mass down there. And the one at the top is always valued as 1 mole, because that the whole thing is the molar mass. So it's always 1 mole there, nothing else. Next is the mole ratio. So mole ratio will be, we position the substances first. The substance at the bottom should be the same as the given, which is KBr. So we can cancel it out. And the one at the top is the one being asked in the question, which is the substance is KBrO3. So KBrO3. That's the substance we're solving for. Once we place those substances correctly, now we refer to the balanced chemical equation given for this problem. We find the first one. It's KBrO3, and it's KBrO3 as the first substance here. Nothing is written on it. If nothing is written on it, that's understood to be 1. So that's 1 mole KBrO3. And the second substance is KBr. Let's look for KBr. That's HBr. So KBr is here. Make sure you don't get lost with HBr and KBr. Okay, so be very aware of what substance you are looking for. So that's a K. So KBr is here. The coefficient is 7. So we put 7 moles KBr. So again, we got it from here. From the coefficient of KBr, we place it here. And that completes our solution. But before we go to the calculation, let's cancel out moles KBr unit in there. We cancel it because we don't need it, and we only need mole KBrO3, which is the one being asked in the problem. So now let's go ahead and put all the values together. So the given times the top values. The top values are kind of easy because those are like 1 after the given. So the given is 74.92, and then you may not place the 1 and the 1, but I will emphasize it here instead, so to emphasize that they're all together, okay? So that you'll get used to it. Then divided by whatever remains at the bottom. So we have 2 numbers at the bottom. We have 119.00 times 7. Okay? Then we multiply top and bottom. 74.92 times 1 and times 1 will just give us 74.92. And then divided by, let's multiply our 119 times 7. So 119 times 7 will give us 833 in the calculator. So let's go ahead and divide afterwards 74.92 divided by 833. So you will get a lot of numbers after that. So you get all these numbers after dividing. We're just going to stick with the 2 decimal places. So that's 0 point. The first decimal place is 0, and the second decimal place is an 8. But 8 is followed by a 9. So therefore the 8 has to be rounded up to a 9. So the final answer will be 0.09, expressed up to 2 decimal places only. And then we should not forget that after the value, we have to copy the unit above, which is mole KBRO3. So mole KBRO3. And that is our final answer for this problem. I hope that you're calculating from your end, and please ask if ever you did not get the correct answer as I have demonstrated it here. So that concludes our mass to mole problem solving. Please let me know if there are questions about this.